Alright, welcome back generals to another Let's Fix the Generals 0 hour to make the best game ever. Last days we have been starting efforts to continue advance the tool unassemblize, originally created by Mr. Omniblade. We want to advance the binary matching efforts for Thyme development. So, last video we did progress here with our PDB reader class implementation. What did we want to do? So yeah, we wrote the load function, and we also have an unload function, and I do realize I think here there's some logical issue here. So if this fails, then we probably shouldn't call this, right? Let's look up this function here. Co-initialize. Co-initialize. Uninitialize. For every successful call, you must call this before the thread exits. Okay, good. Then I think we should say we simply put a bool let's call it co-initialized. Yeah. False. And now we put here let's put an unload here in front. Unload. And here co-initialize equals true, and then on unload we do co-initialized false, and then we also wrap this here if co-initialized, then we put this in there, save, done. Yeah, I think that would be more robust. Not mission critical, but it doesn't hurt to make it robust. No. Good, I think this will work. Good. Then perhaps we should also say that's fine. Good. The next step is we need to start parsing. We need to start reading something from our PDB file. Yeah, I think this will be the goal for today, to get just something started, like start to iterate something and get somewhere with this, right? Without getting everything correct. I think we just want something basic for now. Good, so we have load and unload. By the way, I think load we need to put, there's another problem. We need to have a bool success false, return success equals true, and unload actually needs to always happen because it could fail here, but then we still need to call uninitialize, right? Yeah. Good. Unloads. Good. And then in here we do something like save config reads load unload down so. Yeah, let's for starters just create a like read symbols. How about that? Just very generic without any bling bling. Read symbols. Yeah. And then here read symbols. Yeah. Okay. Oh. And then in read symbols we will basically now start doing what this tool does with yeah, here dump all symbols. Let's go in here. Retrieve the compilants first. Yeah. Yeah. Let's open our Thyme and G all. So here we have symbols, right? Written like, oops. Here, this. Let's search for this. Here. Good. Okay, so the first thing it fetches is this object file, which is nice, but objects. It would be nice to get a file name that is actually in the source. So simng/source/main.cpp and not somewhere buried in CMake files, right? But perhaps there's just a function for this somewhere. Maybe. Yeah, it must be, right? Yeah. Okay, let's start here with this with the same logic. Read symbols. Good. Retrieve the compilants. Oh, this word. Compilant. Okay. Compilant. Seems to be not a valid word. Well, let's add it to our dictionary then. Good. So MP global was, what was it? deassemble this one. Okay, enum symbols. So it looks like this should also return a boolean. Let's do that. Yeah. Let's put the return true at the end. Okay, so enum symbols find children. Okay, then what next? While next. Okay, let's do that as well. BSTR. Oof. You have to free the string. Okay. Did we also copy the comment? Yeah, we did. Okay. Retrieve the name of the module. Good. Let's do that. Let's call this module name. Module name. Let me search for this free string. Yeah. Okay, so we can check for null and then only free it then. Yeah. Okay. So we simply do here if module name is not null pointer, and then we call this free string. Get name. Basically, I would just like to keep the code simple like this. Get name, module name. Yeah, I think this would be simple enough. What's the problem here? P-compilant. What does celt mean? C-E-L-T. Poof. Celt. What does it do with it? Huh. I have no idea. Okay, retrieve the name of the module. Get name. Let's. I think we can remove this comment. Because it's fairly obvious. P compile and get name, module name. So doesn't need a comment. Ah, we have this down here, I see. Okay, so this should already then work. Okay, let's keep on going here. Find all the symbols defined in this compiler and print the info. Okay. Then let's also copy this stuff here. Put this behind here, p compile and release. Let's also set it to null pointer, just for completion's sake. Not that it really matters, but it's always nice. Sorry. Else. It seems to be some kind of confirmation for something. I don't know. But it's weird because it already returns the H results, which is checked here, but then it also checks this thing. Why? Weird. Okay, and then we have here p symbol. Also set it to null pointer. Yeah, and then print simple would have to cater to that. Okay, but this should find all the symbols defined in this compilant. Or let's call this go through all the symbols defined in this compilant. Go through all the compilants. Actually, hold on. Retrieve the compilants. P-enum symbols. Let's call this go through all the compilants. Okay, let's put a breakpoint and see if this already runs. But I suspect it will because we just copy pasted this basically. Yeah, so basically the goal here is to loop through the things that we would like to have and get the data we would like to have. Which should be, for starters, just the function stuff, I think. Okay, we reached this, that's good. Yeah. Okay, symbols, next, yeah. Module name, yeah, main.cpp. And find children. Okay. And so let's shift F11 and done. Okay, and unloads and success. Okay, so this runs through. Good, then we need to start gathering some info here. Okay, let's, how about we first look into our compilant to see what we can get from this guy. So, compilant. So that's the string here. Compilant and so I think this is already part of this stuff here. I wonder if we can get more info here already. What kind of functions do we have there? The problem is like, how do I know which function is valid for which symbol? Like, is it valid to call all of these for all symbols? Like, I guess so many. So many things. I suspect that we would have to. I don't know how I know what is valid to call on any particular symbol. How about we just brute force? We create a function that we can call on a symbol with just all calls. And then we see what succeeds and what does not. And then you can inspect the results, and then we can pick and choose what we like. Yeah. Oof, this would be a lot of work though. Oh boy. Yeah. It's wild. This API is really wild because you have a symbol and you have so many functions for this. But how do you know which function you should call? It's impossible. It's so wild. Poor. Okay. Let's see. Let's try with just a handful for starters. So let's take here the first 6. Yeah. Let's take that. And let's do a PDB reader here. Let's do void test read symbol. Test read symbol. And we How do we do it? Test read symbol. So we have the symbol, yeah. Call it p symbol, yeah. And then we say p symbol gets this, and divert value, and then we do value, and if succeeded, then let's do simply log out for now. Yeah, w printf get some index %u value. Yeah, okay. Okay, and basically we repeat this for all sorts of things. So we know that get name will succeed. bstr. This one will require this free string. What is this str? Is this of white char? So it's this. So it's ls like this. Yeah. Okay, I got lexical parents. Whatever that is. Value. P. Okay. Yeah, the problem is doing it for all different if we do this for all the different functions, it will take a while to set this up. But I don't know how else we can test whether or not a particular call gives us some interesting value, you know? Like there's just so much. So how about we put this now here? So p compilant, for example, right? And then we just put it here, test read symbol, and then p compilant, right? Yeah, and then we put a breakpoint here. Actually, we have a breakpoint there. Oh, let's remove this here. Okay, so and then this should hit, and then we go in here, and now it will tell us whether or not something succeeds, and it does. Sim index ID. Okay, so this is valid. Sim tag is also valid, gives us a value. Get name is valid, gives us a name. Lexical parents is also valid. Okay. this also valid, but the pointer looks garbage. Get type. Okay, this I don't understand. Get type. Like the pointers we get here looks total bogus. Okay, let's keep on adding more things. Wow, this will take forever. Oof. Let's just look at interesting things that look interesting. Yeah, I think these things look interesting. Offset links. Library name. Platform language. Oof. Source file name. Aha. This one looks interesting. Get source file name. Yeah. Get intro. Yeah, let's get this one here. Test. Where's our test function? Here. 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 So let's get name. Okay, let's quit this. Let's look for these things here. Yeah. Okay, let's go back to here. How about we just search? Yeah. So for starters, I'm interested in strings. When we talk about compilant, I'm interested in strings things. So we have get name. Let's add this one here, get library name. Here. Let's create a copy of this. Get library name. And source file name. Get unused. Okay, we don't care. Symbols file name. Yeah, let's get this as well. Why not? Create a copy of this. Okay. And undecorated name. Yeah, that also sounds interesting. Let's see about that. What else? Undecorate options. Okay. Undecorated name exe. I do wonder, is this called here in this program? No. In dir2.h there is this function. I wonder what we can do with the undecoration. Okay, let's keep on looking for string thingies. Here, get compiler name. Yeah, let's get this as well. Why not? Well, for the undecorated name X, how about we... we also call this one. So this one requires an argument. Here, undecorated options. The problem is we don't know what the options are. Yeah, I mean, what are the options? Let's put it to 0 for starters. Oops. Okay, let's go back to the other. Oh, what is this? Okay. Good. Let's keep on looking. So compiler name we do have. Object file name. Okay, let's look at this thing. Object file name. Yeah. Face name. Let's check that out. Face name. Okay, that's it for strings. Not that much. Okay, then how about we simply yeah, we put a breakpoint here and then we run it once more and we check if we get any interesting strings from the compilant or not. Okay, library name is this as well. Okay, that's unexpected. Source file name. Okay, that's weird. Why is it succeeding, but clearly the string is invalid? So I guess this will crash here. Yeah. Hold on. Perhaps it needs to be checked against as okay. Yes, okay. Let's check this. Aha. Okay, so we cannot use succeeded, but we must explicitly compare it with SOK. Okay. Then we need to update all of this. Let's do a find replace. Should be simpler. So we search for this and we replace it with this. Yeah. Okay. And then let's do, we replace this value with this. Right. Let's see. Here. Yeah, apart from this one here. This. Okay, that works, I guess. Okay, let's try again. Yeah. Okay, so we have library name that gives us the same as get name, interestingly enough. Source file name gives us nothing, this nothing, undecorated name nothing, compiler name nothing, this nothing, phase name nothing. Okay, so this name here is the only thing we can really get, and it doesn't look very interesting. Yeah. I mean, main, that's... I would hope we get more interesting names. Let's comment this out here for now. Doesn't seem very useful. Good. Then let's get to the next one here. P symbol. P symbol. Why is it here? Here, here. Okay, so we do the same test read symbol here on the next one. Maybe we can give it a better name. P symbol, what is it? Well, it's symbols, okay. Yeah. Okay, then let's put a breakpoint in here. And let's remove this one here. Okay, save this. Okay, we're making progress, slow. Just learning the API. Yeah. Okay, let's take a look at the strings here. So get name, object. Get name object. Yeah. Okay, library name, nothing, source, nothing, 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 nothing. Okay, so this is some object thing. Ah, it's this thing here. Aha. Okay, then let's get back to our sample project and look here into print symbol. Yeah, okay. Here it gets more complicated. Ugh. Okay. Good. How do we approach this? This one actually has a lot of stuff in here. Oof. Okay, how about we indent? Okay, how about we create a read symbols. Let's create a new function, read symbol. Yeah. And we call it with symbol. P symbol. And yeah, so what we do here is we call read symbol here and pass p symbol, same as our reference implementation. Yeah. 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 Read symbol. Okay. And then in here we start with the same bullshit. Yeah. Tag function. Print sim tag. Okay, so p type. Print type. Okay, let's ulen get calling. Simtag block. What is that thing? Okay, how about we do it? Of course, we do it similar to this. Let's. Yeah. So let's start with the sim tag here. We don't need ulen yet. So syntax error print symbol get symbol tag failed. Okay. And then we do also the switch here. Let's copy this whole switch, which is almost everything. And there's also children. Okay, and then here we say default print name. Okay. I would say for starters, we make them all empty. Yeah. Make it all empty. Start with a clean slate. Yeah, even the function we clean that. Or should we? Yeah. Yeah. Yeah, let's clean this for now. Calls return here. And default. Yeah, default we also just make break here. Yeah, okay, so there's not much going on in here for now, but that's fine. Okay, so basically we should now be able, like when it loops through, actually let's get the stuff here at the bottom. Okay, so symbols can have other children. Yeah, okay, then let's do the same here. Let's remove this. P-child. And then we do read symbol. P-child. P-child release. Let's do P-child null pointer. And here null pointer. Yeah. Okay, so we preserve the same functionality. And then in function, let's also do this then here. I do wonder though, why is this different from the other? What is different here? Let me see. Put this here. Let's find children. P-child, cells. Next, cells. Print symbol. Huh? Looks the exact same to me here, this stuff. I don't know why it's up here the same. I don't see a difference. Okay, so what I think we can do is we simply say here, or hold on. Yeah, here, just these two things, right? Yeah, how about we make switch w symtag, and then we simply have case, oops, case, and then we take these two and we put them here. What is the value? 11, 6, 5, 8. Okay, and then we put here case this and case this. And if that's the case, then we put here this stuff. Yeah. Then we can remove this and this. And this should work, yeah. So basically one of these things, and then we read the child as well, or the children, multiple, yeah. Yeah. I think this would work. Yeah, and then here we would do our function parsing, reading. Yeah, okay, let's put a breakpoint here. Let's put a breakpoint here. And let's see what hits here. Remove this. Yeah. Oh, that fails. Read symbol. Oh, right. Yeah. There we go. Okay. Let's see. Okay, so this hits, yeah. Ah, hold on. We need to change it to a break, right? Yeah, not a return anymore. Oh, now this doesn't hit because we don't have actually code in there. Can we are in debug. Well, we would have to like put a void v, I guess, and then we can put a breakpoint maybe. I'm not sure. Void int v, like that. Oh. Basically, I just want to be able to put a breakpoint. That's all there is to it. Okay, let's forget about this one. Okay, that hits, great. Okay, let's keep on going. So syntax 5, that means it's this. Oh, I hate it when it's an enum. How about we take this thing here? How about we put a syntax enum, call it syntax equals this. What's the problem? Huh? Oh, wow. Okay. So there is a enum value that has the same name as this enum thingy. So we need to type enum and then static cast. Okay, so I just do this so it's easier to actually see it in debugger in the end. I think here we can actually do auto, const auto. Yeah, so this will be now a syntax enum. And auto is okay here because we have a type on the right side. Yeah, and I think then auto is okay if we can clearly see the type here on the right side. Okay, and let's use this here. And here, I think this will make it easier to debug and see the actual type. Yeah. Okay, let's take a look at this once more. Okay, so so we can see now it's SymTag function 5, and then we go here, and it has a children. Okay, what is in the children then? 21. Okay, that's func debug start. So a symbol. I understand. So you have the compilant is a symbol, but then in this symbol you have then all the functions and the enums and stuff like this, and then the function itself also has symbols, and maybe those symbols also have some symbols depending on the type. This is how they made it. So it's just a tree of symbols. That's what it is. And this is how you query it. You just look into the children, and then you go through the entire tree with all the children, and you inspect all the children, all the symbols in the children, with whatever function you want to call on. Yeah, and then you extract the information. And that's how it works in a nutshell. Okay. Yeah, makes sense. Simple enough. Okay, so there's a SymTag function debug start, and it goes in here. Okay, this will be relevant for us, I think. Maybe. Yeah. Okay, that's cool. Okay, good. So we already have the foundation for iterating all the symbols that we have now here. Yeah. Okay, this is good. Good. I think I already accomplished what I wanted to accomplish today, pretty much. But since we are just 1 hour in, we can keep on going and see how far we can get. But everything else will be bonus for me today, because I think this is actually all I wanted to accomplish for now. Yeah, don't rush it. Don't rush. Yeah, not like in the game where you rush all the time. That's not good. Yeah, when you program, you take a good time. Yeah? Okay, so then let's look at our sample code. So there's a lot of stuff here in the function thingy. Yeah. Okay, let's look at this. Print location. Get length. Syntax. SymTag block. What is a block then? What is a block? What is the difference between a function and a block? A block. So this only applies to function, and this as well. Okay, but this to me indicates that function and block should be treated separately, because they only print location and print this thing here. What is this? Undeclared name. So yeah, okay. What is how about we how about we simply check if we have a block in our PDB that we need to care about. So we make a copy of this and we put that here. Then we put a breakpoint here and we see if that hits. If it doesn't, then we have no blocks and don't care about it. Let's see. Okay, it doesn't hit, so we don't actually have blocks. Okay. Then let's leave it in its own category, and we just focus here on our function. Yeah. How about we make a function and call it read function, and then here we do this symbol, and then we call this here. Yeah, I can remove this. I think that would be clean enough. Yeah. I really don't like this thing here. That's bonkers. I mean, it's not wrong, it compiles, but it's not the nicest. Good. So read function. Yeah, so we create a read function. PDB reader. And put a symbol. Yeah. Okay, and in there we start doing things. I think the first thing we can do is let's do our test function here. Test read symbol to see what kind of names we get there for our function. Yeah. Read function. Read symbol. Yeah. Okay, so yeah, we compile this. Okay. And we now can go in here. Good, then let's see what kind of strings we get in here. So get name is, okay, this doesn't help much. Yeah. Type. Library name, nothing. So symbol, undecorated name. Static void. Okay. What do we get here? Same. Compiler name, nothing. Object, nothing. Face name, nothing. Okay. So it's undecorated name and, well, is there anything else? What about get name? Yeah, get name. Okay, that's just yeah. What about a decorated name? How do we get that? Get decorated. Oh, this is wild here. Yeah, so, but in this file, there are definitely undecorated names, right? Type diff. Okay, so here's the undecorated name. Static. Yeah, okay. This is also undecorated. Yeah. But so to me it looks like we don't get the decorated names in here, right? Undecorated. So if we go here, further down, public void. Okay, so here are our decorated names here. But these seem to be queried differently then. Section contribution. Okay, let's see if... Let's search for this string here. Well, what is here? Let's just search for this. Aha, there are multiple places. 2 places. Publics and publics. Publics. Modules publics. Okay, that's wild, the symbol here. Public. Ouch. So there are a bunch of values here. So what if we search for this value? Do we find it elsewhere as well? Aha, here. Okay, so there's some association here. Aha. I see. And also here. Okay, so we link these with this value here. Yeah. What about this other one here? This one? ASCII string. Okay, this is also nice. So this one tells us exact the source file. Okay, so we would definitely be able to get this info. We just need to. It looks like we need to look through different things. Yeah. Okay. Yeah. Okay, so basically with these numbers, we identify this function. It would have been cool if all the information were just queryable from one place, but it doesn't seem to be this way. So publics. Let's look at publics. Let's search for publics. Dump out publics. Print public. So, okay, so we also need to loop this thing here. Publics. Okay, let's take this. Where do we do this? Retrieve the compilants. I would say we simply put it here. Publics. Symtech compiler. Retrieve the public symbols. Okay, then how about we put this here into this? Read symbols. Okay, how about we create functions here? Read public symbols and read compilants. Yeah. And then we put this here. Okay. And then we copy this down here and this, put this in here, and then in here we do read public symbols and read compilants. Yeah. Okay. Print public symbol. Print public symbol. Okay, we need to, yeah. We need to study this a bit as well. Let's stop debugging. Okay, let's Okay, so P global, what was that again? It was this one, right? Yeah. Okay. Okay. Okay, let's look into this function here. Syntax thunk. Get relative virtual address. Okay. Relative. Okay, I see. We need to. Good. So we iterate through different kind of symbol tables, so to say, or trees, symbol trees, and yeah, we need to combine it into one result. So if we want to have like metadata for function, then yeah, we can combine this essentially. Yeah. Okay. Good. Then let's rename this to read compilant symbol, and this is reads compilant function. Yeah, and then here we do bool reads public symbol, and that also takes this symbol here. Yeah. Oops. Okay, and then here we put read public symbols. Okay, read public symbol. Yeah. And in here, yeah, I think for starters, we can just copy this code. And we can... Yeah, we can... comment this. Comment this. Okay, something is wrong here. Okay, looks like we just make it a void. Okay. Okay, let's make a test here. So read public symbols. Then let's do here read public symbol, p symbol, and then we also set it this here to null pointer, even though it's not really necessary, but for completeness sake, let's do that. Good. Yeah. Okay, this should work. Read symbols. Ah, okay. To will success equals true. Success and yeah, I think that's correct. I think so. Return success. Okay, let's see. Put a breakpoint here. Read public symbol. Return true. Okay. Then let's see. Undecorated name. String. Oh. Okay. That's a little bit unexpected. For BD8. So it's this one here. So this string is that. Here, there. I see. Combined. Okay. I see. Okay. So this undecorated name. Okay, it's this. I see. Okay, but this we should treat differently, right? So if I if I search for this, do we get also other hits? Ah, yeah, okay, it's this one. Get name. Uh-huh. Mm-hmm. And it's also here. Okay, so here this is our public symbol name. Then this is our, I don't know, undecorated name. Yeah. And what is this here? Globals. Globals. Okay, we also need to look into that. Yeah. Okay. Okay, but this is already good. Yeah. So I mean, obviously there's still stuff we need to do here, but this already is something we will definitely need here. Yeah. Okay, good. Good, good, good. Then yeah, this should work. Okay, good. Runs through, no crashes, good. Then let's look at this thing here. What is that? So okay. So basically here we have some other kind of string, which again is different. Well, it's this one here. Yeah, but where do we get this thing? So we have globals. Globals, okay. Then let's search for this here. Yeah. Globals, there we go. Okay. So we have... before we do this though, let's also make this more readable like we did here. Symtag. Here. Symtag. Symtag thunk. See, function or data symbol. So does this mean there are two types here? How about... Must be a function or data symbol. So either this or this. Okay. How about we do switch. I mean, for starters, right now we are only interested in functions, nothing else. So I think we can delete this thunk thing. Okay, so we have Simtech thunk. Then let's put here switch and case that Simtech, and then we do case, what is it? Print global symbol. Global symbol. Okay, what's different between global and public symbol? So this looks very similar to our public symbol, right? Very similar. But what's the difference then in the call? Okay, let's worry about this afterwards. Okay, so for starters here we have Simtech thunk and Simtech data, right? Okay, Simtech data break, and we have case Simtech function break. Good. So in thunk we just do nothing. So I think we can remove this. And then reads public. How about we do here as well void reads public function. Yeah, I'll put that here, reads public function, p symbol. And then here we have this reads public function, and in there we put this stuff here. Okay. I think actually we can take this whole stuff here. This stuff, that. Put that in here. And then we clean this up here. Let's also copy this over here for now. Okay. And then here we can remove this and this. Yeah, that looks good. Maybe we should also have here this. Okay, so it's now similar to what we have here. It's easier to follow the flow. Good. And then obviously here we need to continue doing stuff later. Okay, well, it's a lot of boilerplate here that we are going through. Okay, and then the next thing will be the globals. Yeah, dump all globals. Because globals again, they have. So we have this here. Yeah. Okay, so basically the print, let's go in here. Yeah. Yeah, okay, so here get name, basically this will return this here. Okay, so basically we will have 4 different strings for functions, if I'm not mistaken. 4 different strings. Yeah. The mangled name, then the short one here, then this one here, and then there was one other. There was one other. No. No, it's just 3. It's this one, it's this one, and it's this one. 3 strings we have for functions. Okay, good. And let's try to gather all of them because it's yet unclear to me which one we eventually end up needing, right? So might as well just get all of them. Doesn't hurt, I guess. Yeah. Good. Good. Then we need to also do the global symbol. Global symbol. Yeah, here, dump all globals. Okay. So we have publics. Okay. Then let's put the globals at the end. So we do a read public. I think the order we have here doesn't match the order in our CPP. We should probably fix that. Let's take this and move this up here. And then we take this and move it here. I would like to have it in order, matching the header. Yeah, good. Then we need to read. What was it? Globals. Read globals. And then I guess we will have the same kind of style here. Global symbol and global function. Yeah. Yeah. Okay, then let's implement that as well. So read symbols, we need to call globals, globals. Well, why don't we call this here read publics? Rename publics. Yeah, then the naming is consistent, right? Good, then we go down here. We need here to do, and here as well, to do, to do. Okay, so we got this, that, and that. PDB reader. Put that here and there and there. And then good. Then I guess we need to copy this garbage here. Read globals. Okay, so enum symbol. Well, we are only interested in functions really, but might as well for starters also search through everything so that at least we know what is possible. Yeah. Yeah, I would say we'll leave it like this. It's okay. Even if we loop through something that we don't need, for documentation purposes, it's good to know what is actually possible, right? Good. So we got count of that, count of, and to me the code seems to be very fast actually. Like when we run this dir to dump, it runs lightning fast. So to me, it seems this API is very fast. Yeah, good. So we got this. Please, let's change this to a null pointer here. Yeah, actually, yeah, null pointer is good. Good. Let's change this to plus plus I succeeded. Okay. Dir symbol succeeded. Yeah. Print. Okay. So remove this. Actually, this is then read global symbol. And then p symbol equals null pointer. And this null pointer. And dump error. Error. Okay, let's here. Read globals return no symbols. Okay. Good. Okay. Let's compile this for starters. Yeah, compiles good. Then yeah, so this will be to do. Okay, so read global symbol, then let's go into this function here. Okay, so this looks very similar to the other one. Yeah. Yeah. So I think what we do is we simply copy this here. Copy this in here. And read global function. And yeah, and in here we do this stuff, which as well looks very similar to what we do with the other one. But the difference is that this thing here will return a different name, right? Okay. Free string. Okay, let's remove this and that. Okay, let's compile this thing. Okay, there's an error. Ooh. Looks like we forgot here one of these. Okay, then we also need to get here into our to-do. Let's also get the sample that we have here, which was where? Dump all symbols, print symbol, and I think it's this stuff here. Print location. Yeah. Get ready to compile. So let's look at this thing here. Yeah. So this gives us, yeah, so these are the children here, these things. So func debug start, debug end, and some data. And label as well. Labels. And more data. Reframe. What is all this stuff? Data. Labels. Yeah, so yeah, so my understanding is that this minus this is the size of the function in the assembly. And this one is the same, but it has a different offset by 1000 here, 1000 hex. I have no idea what this stuff here at the bottom is, but then I guess we don't care. Yeah, we probably don't care then. Okay, but let's take all this stuff here and put this here. And oof. Okay, we have ulen. Get length. What is this length? $61. So does this match this here or not? Let's take a calculator. So this, this minus this is 58. 58. What about this the same? Okay. Yeah. Okay, so 58 hex. Yeah. So 61. So that's 88. And 61 hex is 97. It's much longer here. This len. I don't know if it's... Let's look at some other here. This minus this 13C. It's again smaller than 151. Yeah. But it's also... Yeah, I don't know. So maybe this is not the actual length. Maybe this is the length of the assembly function. Maybe. Ah. Maybe in the assembly there's additional... Maybe there's some padding behind or some additional data that is not part of like the code, right? So maybe this is really purely the code, but this then length encapsulates something else as well. That could be, right? I don't really know, but we can experiment with this later on, right? We can take this length. Let's see what happens. Yeah. Okay. Good. Then let's simply comment this stuff here. Oof. Print location. Print location. Oof. Okay. Oh. But it probably will be this. But we have seen this already in the other functions as well. So it looks like we get this from any function place. Yeah. Yeah, let's okay, we can remove this here. Yeah, so basically we probably just need this here. It's, yeah, I mean, we take it from either place. It's always the same. This relative, then this, yeah. Okay. And we can remove this here. Okay. Okay, print this here. What is that? Undecorated name, get name. So that will be so this seems to give undecorated is this. No. Okay, I don't know what this will give. Let's just copy this. And we will see then when we debug this. Okay. So I got this, and here we can remove this again. And put this here. Yeah. Okay, let's remove this. Yeah, I mean, we will delete a lot of the stuff here, but I just have it here for reference now, so we can see what is going on. Good, so that's our reference material. I guess this should compile. No, redefinition. Then we just remove this here. It's kind of weird that I see now. Okay, hold on. Get undecorated name. If that fails, then it will get this as a backup name. I see. I see. Okay. Yeah, we will see. Okay. Good. Then I think there's just one thing missing. We need to handle these things here. This. I don't think we care about the data and the labels here. That seems to be not so important, but we probably need this here. And this is part of this here. So we create another new function, read void read compilant compilant function debug range. I don't know. Well, let's create function range. Yeah. Maybe that's good. Okay. And I put that down here. Okay. Okay, and what do we do in there? Wait, we need to call this first. Here. P symbol. Good. And in there we do yeah, let's get to that. Let's put a note here. Function provides a lot of skeleton functionality as seen in what was the name? Dia to dump app provides this function provides skeleton functionality as seen. Yeah. Then we say it's the same here. And here as well. Good. Just to clarify that, yeah, it does these things, they're empty, but who cares, right? Good. Especially here, and there's a lot of empty stuff, but that's fine. Good. So this function range, what does the original do there? Well, let's search for this. Print location. Okay. Get location type. Okay. Static. Let's search for this here. Find all in current documents. Okay, it's always static. Yeah. So it's probably this here. Get location type. So I guess what we do is we take this and here we do also to do and get location type. It must be a symbol, optimize code. Yeah, so I guess it's the same what we do in all the others here. This. Yeah. Well, let's just for now do this. I would say TV log type. Yeah, I would say we do here assert get location type equals that's okay, and then assert db log type equals log is static. Yeah. Okay, so we got this section of. Okay, then we remove these guys. Remove this, this, and this. All this. Okay. Yeah. But hold on. Front location. I think we need to. This needs to be different because they are two different ones. It can't be two. So this is reads compile and function start and function end. Yeah. We make a copy here. Start end. Because essentially in the end we need to process them differently. I mean the result of them needs to go to different places, so should have two functions for this. Yeah. Okay, so what we have now is we have all the looping, all the visiting all the necessary tree leaves to get the data. We have all mock functionality here to read the data, but the next step will be to actually just read what we need and put it into data structures that we can then later dump into our config and use for processing, right? So right now it's just lookups, but we need to gather the data and dump it in actual data structures in this class PDB reader. Yeah, that will be the next step. So here, I think what we do is we simply copy this into both of these here for now. Yeah. Okay, and let's remove this one here. Okay, good. Yeah, then we need to, hold on, we still have an error here. Yeah, this, and this is correct. Okay. Okay, yeah. Okay, looks pretty. Yeah. Good, then let's compile and see if it runs. Yeah, good. It compiles. Okay, so basically we need to implement these two functions, this function and this function. Yeah, all the other things are done. Let's put a breakpoint in here and in here, here, and here as well. Okay, let's see if all the leaves are being called. Yeah, publics. Let's remove this. Okay, function start. Interestingly, this is called before. Oh, we didn't put breakpoint here. Okay. Yeah, so static, yeah. This succeeds. Okay. Good. This looks good. And then this should be the exact same. Good. So you can remove these. This looks fine. Okay, compile and function. Let's go through this here. Length, yeah. I've got here some number. Call. Get calling convention. Okay, here we need to figure out what then. We probably don't care about calling convention. Yeah. We call mostly about the names and the addresses. Yeah. Interesting that it has these has this and that functions. Has allocate a, set jump, long jump, inline assembler. Interesting. It's naked. It's naked code. Yeah. Okay, that's good. Yeah, that looks fine to me. Then let's remove this and global function. That's the last. And that basically also gets the addresses here. So we will use the addresses or this name. If I'm not mistaken, there was this one string which is used in all three sections. This one. Yeah. So this string is always the same. So we can either look up the function with this string or with these locations here. Both of that will work, I guess. Yeah. Good. Yeah, get name. It's this one here. Undecorated name. Yeah. Okay. Free string. All right. Okay, cool. Yeah, I'm very happy with the progress, even though we don't have like a tangible result yet. We got all the boilerplate code in place. And then we can actually start extracting the information. Okay, great. This test read symbol, I think we don't need that anymore. Actually, hold on. We would like to have main CPP. Aha, right. Compilant. Files, compilant. Man. Yeah, let's search for more. Lines. What is this? So this maps lines to addresses. Yeah. This maps lines to addresses. This is nice. This is nice because this allows us to actually map the assembler code to C++ code. Yeah. This is nice. I don't think we need this for starters, but perhaps we can also get the boilerplate code in place for this. Yeah. Yeah. Okay. Compilant. Yeah. Compile. Okay, it looks like we will need a little bit more boilerplate code before we start tackling the to-dos. So basically, first we want to get this file name as our compilant name. I don't think we really care about this name, but we care more about source main.cpp, right? This is what we would like to have. On the other hand, it probably, I think maybe the name of the compilant doesn't really matter. As long as we have a name or something that describes which kind of functions are within this one unit, right? So in this case, in this case, all the functions that are inside main.cpp are part of this compilant, right? So actually, it's not just that. If there was a template function in this header, then the template function would also be part of main.cpp because template is always inline. So I don't know. Maybe we go. Let's open this main.cpp. Here. Okay, so So line 15. Perhaps lines. I think what we can do is, if we have a function, with the function we have this, and so if this line refers to this file, then it must be in this file, right? Aha. Yeah. So yeah, so I guess we map it with, we have here these addresses, and then we need to look at this, how it's done in the sample, and then we look up this here, like this file, and then, yeah, just that. And then we know what file this is definitely in. Yeah. Yeah. Then, okay. Okay. Yeah. That is interesting. I mean, that's CPP. Finance. Okay, I would say for starters, we don't care about this association here with code to lines, because we don't need it right now, right? So maybe we can just create like the high level functions to like iterate this here, but we don't go too deep and we don't try to implement this yet because we don't need it. But I would like to figure out the compilant name, or what all belongs to a compilant. We need this association, right? And for this, I think we can use this. Let's see how this is implemented. Yeah. Okay, dump all lines. Yeah. Section contrib, get table. Okay, dump all lines. Okay, so if we look at this thing here, so there is line 15, 16, 17, 18, 19. Let's look at the file. See here. Okay, so it's these things here. So this len 16, how much is that? 16, it's 22. Okay, what does that mean? 22 len. This is 22. Somewhere here. I don't know what this len stands for. Okay, what about line 22 here? Let's see, line 22. Len 1. Okay, this would match this one character here. What about this one? Line 21. Here we have 96. And here we have Line 23. A. A is 10. Okay, I don't know what this... no. Yes. Len, aka... I see, okay. Now, so it's basically the diff from here to here, right? So if we take this, what? This minus this is A, yeah. Okay. So basically line 23 here corresponds to 10 assembler, 10 bytes in assembler. That's it. Okay, I see. Okay, nice. Okay, cool. And how is this association made? Get table, get red, dump all lines. Find lines by RVA. What does RVA mean? RVA. RVA code meaning. Okay, virtual address. Relative virtual address. Okay, that makes sense. Relative virtual address. Okay. Okay, so print lines. What does it do? Oh. P lines. Line at get source file. P line get source file. Okay. It's pretty cool, yeah. It's pretty cool. Yeah. Print lines. What's the time, by the way? 2 hours 35. Yeah. Yeah. Get source file. P source. So this get source file. It's probably also called elsewhere, isn't it? No, it's not. Huh. What about this one? Okay. Find lines by RVA. Print lines. Dump all lines. Aha. Okay, so it looks like once we have this virtual address and the length, then we use this to query the lines. Like it's like this find function, which does the finding for us. So it sounds like after we have all the intel on our functions, we could then use this to also get the code lines. And perhaps we just say, like, we could say, hey, just give me just the address and range 1 byte, and then it would just return first line, and with this we get the source file. Yeah, like that. Okay, so dump lines, p session, p global, dump lines. Calls itself? Ah, there. Okay, I would say we worry about those lines later. Yeah. I do wonder, is there a way to simplify these things? So right now, here, okay, syntax public symbols. Enum symbols, yeah, okay. Compilance is different tag here. What kind of tags do we have here? Oof, I see. It's compilance. Read compilance symbol. Yeah, it's a bit strange that we have to like look at 3 different places to get all our infos for the function. That's kind of strange. So if we call, so we have here get name. We have get name here. Okay. Good. Let's comment out this function here. Probably don't need that anymore. Let's compile. Yeah. So, okay, so with the dump lines, it doesn't look too complicated. Once we have all our addresses for the functions, then we could just look it up here. This is call here. Yeah, this looks simple enough. Yeah. Okay, but the compilance thingy. The question is, do we just go by the compilant, or do we actually go by file? In my opinion, I think compilant is actually not the right thing to bundle these, because there are build systems that take multiple CPP files and bundle them into one compile unit. And then I suspect that multiple files could be part of one compilant, but that's probably not what we want. We want certainly one, but it's a PD. Yeah, PDB is after compilation step. Yeah, so I suspect that the compilant could also have multiple CPPs inside. There are these things to speed up compilation times. So perhaps we don't want to sort them by compilant, but we say we have all the functions, and then we look up in what file they are, what source file they are, and then we assign this, and then we can sort them by this. Yeah. Okay, then do we already want to write the boilerplate code for this? Let me see. Dump all lines. P-session. Dump all lines. Yeah. P-session. Dump all lines. What is this here? Enum sec contrips. Enum sec contrips. Files. I don't think we need to do this here. Yeah. Yeah, let's copy this here. And do a void read find lines. Let's call this read source. No, let's read lines. Read lines. That's what the original calls it. Okay, and in there we put this here. Yeah. Read lines. And put it here at the bottom. Read lines. And that will do retrieve and print the lines. Retrieve and go through the lines that correspond to a specific. I already forgot what R means. R virtual address, relative, right? Relative virtual address. Okay, so and this also does MP. Oops. Dear session. We also need to bool. Okay, bool. And return true. And let's look into print lines. Let's copy this thing here. Put that here. So let's put also p lines null pointer, p line null pointer, print source file. Let's comment this. P source null pointer. Yeah. Like this. Source ID. Yeah. I see. So according to this, it looks as if it would be possible that there could be multiple source files somehow. Because if this would return a value that is different from source ID last, after it was assigned here, it would then again enter this here. But so I suspect they deliberately wrote it like this to handle this case. Otherwise, they would just say, if first, then do this, right? Read lines. Hold on. No. It's because they give it like a huge range, like who knows how much. Yeah, okay. That makes sense. And then they just plow through it and then they hit over multiples. Okay, I see. Okay. I see. Read lines. Okay. Yeah. Yeah, then in here we can do our logic to assign the source file name and categorize the functions. Yeah, it should work. So basically what we do is we call this function here with an RVA with the virtual address and the range like 1 byte, right? And that will give us one line, and that will give us the source file, and then we take that, and the rest here we leave for now, and we can use this later if we want to get more into like the actual line number mappings, but we don't need this now, so don't need to over engineer it for starters. Yeah. Yeah, I think this works. Let's compile this. Hold on, we forgot one thing, and we also have some D words unknown. Okay. D word header. Int save. That sounds suspicious. Include int save. Oh, that works. Okay, here we have a problem. I wonder if we should make another smaller function read line, but then we cannot do this here. Actually, we can. Let's do read line here. And oops, that is called with this here. This is this. And there's p-line. Yeah, p-line. This placement here looks incorrect to me. This should be down here. Yeah. So there's actually a bug in the original. Read line. Read line. And then we need this here. this p line, and we take this thing here, and what is it? So should be a struct, right? Struct that, and then we put this down here, put here to do, and in there we put cells. We put these things here, and these things, and then we put here this, and call read line p line, and pass this thing here, and that's it. Yeah. That should do. Yeah, and then in here we can assign the source file and stuff like this. Okay. Good, this should be the boilerplate, all the boilerplate we need, as far as I can tell. With this, we should be able to get all the relevant information from the for the functions, all the different names, the addresses, and the source file name, and yeah, all this. What's the problem here? Read line. Yeah, let's make it a void. Void, and I think in read symbols we also need here read lines here, read lines, and that we put to, oh no, read lines we have to yeah, we have to invoke it later on with like a symbol. Like read line, we pass it like a symbol that we have, like from one of our internal data structures. And then that's how it's being processed then. Okay, so it's not part here. Let's just put a comment here. Oops. Read lines, ... Okay. Let's do a to-do read lines. Okay. Actually, let's do it with hash, makes it fatter. To-do. Good. I'm very happy with the progress. I think I got done more than I initially tried to do. But yeah, we got all the foundation, everything to look it up, I think. Yeah, so the next step will be to actually really just call what we need to build the data that we need. That also means we need to think about our data structure. It should be similar to what the executable is doing here with the symbols, but I don't like this structure because it's a STD list. It's really bad. Yeah, so we probably need this symbol. Yeah, need to see. Okay. Good. Yeah, let's compile once more. Okay, good. So we leave it in a good state. That's great. I don't commit it yet to source because, yeah, it's just a mess so far. Yeah. Then next time we pick it up here and continue with that. Let's see our time. 3 hours. Perfect. Let's see if there are any more interesting discussions here. Oof. Okay. They are currently investigating Macintosh or Mac O symbol data because we have a new plan. Today we're brainstorming the Thyme developers, and there is an idea of dumping the symbols from the Mac O file for 0 hour and like gathering all the information that we have that are definitely correct and generate C++ skeleton code for all things that we know will be correct. So that we have like an absolute perfect starting point to get absolutely clean code that we can then compile with Visual Studio 6. And then we can drop in our code and then later on binary match once we have that tool pipeline all established. Yeah, which obviously we don't because I'm still working on this right now, as you can see here. Okay, but we made progress. 3 hours we filled. Look at that. I thought I was done at 1 hour, but we had 2 more busy hours. Good, I think perfect. I think we got good progress. We learned something. We have a clear plan. So now it's just monkey work. The monkey work to gather all the data, bits and pieces, and then we will get something. Yeah. Okay, great. Then I will end this video at this point. I hope you enjoyed. I wish you a great day or night. Until next time, goodbye.